Hello, my name is Craig Lefkowitz, and I'm a senior developer advocate with AWS CloudFormation. And today I'm going to be talking about managing infrastructure with Git, first principles of GitOps. In this presentation, I'll start by talking about DevOps. Then I'll get into treating your infrastructure as code. We'll talk about how to manage and provision your infrastructure now that it's just code. We'll then get into why you should use GitOps, and then I'll show you a typical workflow. Before we get into GitOps, we need to talk about DevOps first. DevOps is three things. It's a culture and practices, and it's the tools that enable them. Sometimes people talk about DevOps as just a tool set. We do Jenkins, all the pipelines belong to us, we are a DevOps team. Or it's just a culture and a mindset. DevOps is the intersection of three things. Let's break each one of them down. The philosophy of DevOps is to bring two teams together that have traditionally been siloed, development and operations. In the days of old, developers create applications and then they throw them over the fence to operations. I've been guilty of that too. Whenever you structure teams where handoffs occur, it's going to cause bottlenecks and churn. So if you remove these bottlenecks and these handoffs, we get a single team that owns the product and they have a greater stake in its success. So what do we need to do in our day-to-day lives to implement this philosophy? Well, we need a single source of truth for the intended state of our resources. This allows the team to work from a single sheet of music. For teams that have to manage infrastructure, this means that we codify our infrastructure using declarative structures that describe the intent of its state. We establish clear patterns of communication in the forms of code reviews, issue tracking, and pull requests. We look at our manual processes that slow us down, and we codify these processes into automation. And this doesn't have to happen all at once. Automation will happen over time. For example, if during every code review, we see the same issue over and over again, say YAML code that's not syntactically correct, we'll add a pre-commit hook to our version control system that rejects commits that have invalid YAML. This enforces errors to be caught early before code reviews, which are expensive from a time perspective. And we need visibility into our systems. We can't manage what we don't monitor, so we need to implement monitoring and alerting mechanisms that deliver feedback to let us know the state of our deployed infrastructure. The tools that we use to implement all of this start with a version control system such as GitHub or CodeCommit. Version control is the foundation. It's the single source of truth that describes the state of the system. Attached to your version control systems are continuous integration and delivery systems such as CodePipeline, Jenkins, and Travis. These orchestrate the execution of the intent stored in version control. And finally, you have management and logging systems that monitor the health of your deployed systems to validate that everything is working as expected. And importantly, your deployed systems configurations haven't drifted from the state that's in source control. So let's talk a bit about treating your infrastructure as code. Developers have been coding applications for decades, but codifying infrastructure may be a relatively new concept, which is called, surprisingly, infrastructure as code. Writing code for infrastructure has a best practice of defining your infrastructure in a declarative manner, meaning your code describes the intended final state of your infrastructure and not the steps it takes to get there. Your code represents the what rather than the how. So let's take a look at an example. This is a fairly simple CloudFormation template. We have two resources, a code commit repository, and a Cloud9 environment. The Cloud9 environment references the repository, which is a dependency. If we were to use the AWS APIs to create this infrastructure, you would need to call each individual API in a specific order. First, you would call the API to create the code commit repository. You would then wait for the repository to stabilize and become available. After that, you would query the newly created repository, retrieve the URL from that repo. You would then create a Cloud9 environment and wait for it to stabilize and become available. You would then SSH into the Cloud9 environment. You'd run a git clone on that Cloud9 instance, and so on and so forth until you got your infrastructure provisioned. Now, this would be an imperative approach to creating infrastructure, and it's similar to how you write code in a language such as Python, TypeScript, or C#. However, in our CloudFormation template, we're taking a declarative approach by simply listing the resources we want deployed. CloudFormation reads our template, calls the underlying APIs in the correct order, and it implements the desired state specified in your template. So let's take a look at how CloudFormation deploys the infrastructure codified in a template such as this. After you code your template, you would test it and review it, send it through to the CloudFormation engine. CloudFormation will then bundle your resources in a template into a logical grouping called a stack, and then resources are deployed. After the resources are provisioned, the system checks for drift between the resources defined in the stack and the live environment. One of the fundamental benefits of GitOps is to reduce drift by routinely checking your live state against a single source of truth, the Git repository. So what if your team is not familiar with YAML or JSON? Maybe you're more comfortable working in TypeScript or C#. That's perfectly reasonable. There are many methods for managing infrastructure as code while still preserving the core fundamental of a declarative approach. The AWS Cloud Development Kit, or CDK, is one example of providing a declarative method of deploying infrastructure using familiar developer-centric programming languages such as Python, JavaScript, TypeScript, Java, or C#. Here we see two examples of infrastructure as code. The example on the left is written in TypeScript using the CDK. The one on the right is a native CloudFormation template written in YAML. They both accomplish the same thing, deploying infrastructure declaratively. They just use different languages to get there. The CDK is a layer on top of CloudFormation that allows you to use your favorite language without deviating from the best practices of a declarative approach. Constructs are used as base building blocks. They can be as simple as a one-to-one mapping of a CloudFormation resource, such as an S3 bucket or a Lambda function, or they can be complex patterns that contain multiple resources. When you're ready to deploy your infrastructure, you run CDK build or CDK deploy, and your code is transparently synthesized into a CloudFormation template, which is then deployed in CloudFormation. So you've likely heard about GitOps by now, but so what? Why would I use it with my infrastructure as code? How does that help me and my team? So in most, if not all DevOps teams, you'll have two personas, development and operations. Operations teams usually have a deep understanding of the underlying infrastructure where the development teams run their applications, but they don't have a deep understanding of the needs of the application. The operations team is hesitant, and rightly so, to allow the entire development team direct access to the infrastructure. Plus, they want to enforce consistent standards across the organization. So in our pre-GitOps world, let's say a developer opens a change control ticket asking for their app to be deployed into production. Operations reads the request, they interpret it, and they fulfill it in a day or two. The developer finds out that the app is going to be hosted in a containers environment and those containers are ephemeral. They get created and destroyed at will. Well, that's not going to work. My application isn't designed for that. That means that I'm going to have to rewrite my app, or I'm going to have to get an exception to put this app on different infrastructure. And that's going to cause a bunch of churn for me. I'm frustrated. Operations team is frustrated. My manager is frustrated. But no one individual did anything wrong here. You've got experts in clear roles, and you have a separation of duties that needs to be enforced. But obviously the team has a communications issue. So let's look at this scenario a little bit differently using GitOps. What if you allow developers to configure their own infrastructure? Well, that would be crazy, says me, a former systems administrator. Developers shouldn't have access to those things. It's dangerous. However, we're in a golden age of infrastructure, with the advent of public clouds, where infrastructure is defined by APIs and by extension code. We have tools such as CloudFormation, CDK, Ansible, or Terraform that allow us to describe that infrastructure declaratively. So we don't have to know the implementation details of, say, opening up some ports on a firewall or configuring a load balancer. Since infrastructure is now code, and we can store all of our code in Git, we can use pull requests as the basis of our change control process. So in this scenario, operations provides access to the infrastructure configuration through Git. Everyone now has visibility into the state of the system. They can understand the boundaries of the system by reviewing the automated tests that'll be run against their infrastructure and configurations. Instead of a change request or a ticket, they submit code that can be tracked and reviewed throughout the entire process, from source all the way to the live environment. This reduces the burden on operations by delegating infrastructure configuration to developers, but with published guardrails that reduce churn. Operations still has ultimate control in the form of code reviews, but now they're done through pull requests. And with automation in place, such as pre-commit hooks, it should be a relatively quick process, because that code has already been vetted and through that automated testing. You now have a single source of truth that's transparent, and you can follow that change through the system all the way to the live environment. And that live environment is constantly checked against source to ensure that nothing is drifted. But don't take my word for it. Kelsey Hightower, a developer advocate for Google Cloud and formerly CoreOS, shared this tweet back in 2019. The key takeaway is that declarative configurations, along with strong collaboration, is needed to properly deal with systems at scale. So let's look at a typical IAC workflow with CloudFormation. I call this the happy path because it assumes everything is approved and no errors along the way. I'm sure this is how it works everywhere. So after your code complete, you commit to Git, which generates a PR, or a pull request. That pull request is reviewed and it's approved. The approved code is merged into the release branch, which triggers your continuous integration and deployment pipelines. That code moves through the system, it's tested, and it's submitted to CloudFormation. CloudFormation reads the template, resources are provisioned. Once deployed, the system is routinely compared against the code and source control, which is your source of truth. If the system drifts from the intent described in code, it's remediated. Everything starts and ends with Git. So let's take a deeper look at that step. The foundation of this workflow is that code lives in a version-controlled repository, namely Git. In order to keep everything flowing smoothly, you'll need to employ some strict controls in your Git process. For example, you should be using branches. Now, there are a ton of branching strategies, but I'm going to give you a simple example of one that I've seen used. You start with two long-living branches, main and release. Main is the branch that's your source of truth. It represents the system running in your actual environment. The release branch is the branch that kicks off your pipeline, and that's when you have that change that you want to release, you put it in that branch. No one should be able to push code to either of those branches directly. Instead, developers submit their code for a review by pushing their code to a short-lived feature or development branch and create a pull request. After the operation teams review the code, they merge it to the release branch, and it's sent on its way to the CI/CD system. Once the change reaches the live environment and it's deemed stable, the release branch is merged into main. So it's important that Git is the only entry point for change into your systems. It has to be your source of truth. Otherwise, you're going to get drift, and drift is bad. You're going to want to constantly monitor for drift. So I have a short demo on detecting drift with CloudFormation. So let's take a look. Let's take a look at a drift detection demo using CloudFormation. CloudFormation has a feature called drift detection, where it'll check the resources defined in a stack against what's running in the live environment. So let's take a look at an example stack that I've set up. If I go into this stack here, and I take a look at its template, I see that I have a single resource. It's a DynamoDB table, and in its properties, I have read capacity units of 5 and write capacity units of 10. So I can go into the drift console, and if I click detect stack drift and I refresh the page, I see that I have a drift status of in sync. And that's expected because I just spun the stack up and resources were just deployed. So everything should be in sync. But let's say that I go into the DynamoDB table directly and I make a change that's outside of CloudFormation. Say that I change the read capacity units to 6. At this point, if I go into the CloudFormation console and I check for drift again by clicking that detect stack drift button and I refresh the page, I see that the drift status is reporting as drifted. I could even go into the resource drift status panel and click the view drift details button, and CloudFormation will tell me that it expects that the read capacity units are to be 5, but it's reading 6 in the live environment. So let's fix that. Let's go back into the DynamoDB table and change those read capacity units back to 5. Click Save and go back into my stack to the console on the drift. I go back into the drift console, click that detect stack drift button and refresh the page, and my stack has a drift status of in sync again. So that's great because I have a mechanism for detecting drift. But right now it's a manual process. I have to go into the console and click that button, and that's definitely not something I'm going to want to do on all of my stacks every day on a set schedule. I'm going to want to do this programmatically. So I want to implement a Lambda function that periodically checks all of my stacks for drift, runs a report, and anything that's drifted, I should get an alert on. So I found a good example that does just this. So if you go into GitHub and you search for stack drift notifier, it should be one of the first repositories that come up. So let's take a look at the architecture of this solution. What this solution does is it deploys a Lambda function into your account. That Lambda function is invoked at a specific interval Could be 5 minutes, could be a day, whatever you want it to be. And when it's invoked, that Lambda function will enumerate all of the stacks in your, all of the CloudFormation stacks in your account, and it'll check each one of them for drift. If any of those stacks are report as drifted, it's going to send an SNS message to a specific topic. As built, that solution has a single subscriber. It has an email subscriber that emails you anytime it detects drift. But I'm super fancy, so I added another subscriber to that topic, a Slack provider, so that anytime drift occurs, I get a message in Slack. So let's take a look at this in action. If I go back into my console and I navigate to this the function that solution creates, and I click the invoke button, simulating the CloudWatch event that would normally pull this every hour or every 30 minutes. I see that I have an execution result of success, but if I go into my Slack channel, I see that I haven't received a message. And that's strange, but actually it's not, because all of my stacks are in sync. So that makes sense that I didn't get any alerts. So let's change that. Let's cause some drift in the environment. If I go back into my DynamoDB table and I change the read capacity units to 6, which will cause the live environment to differ from the definition in the template, and I run my Lambda function again. There we go. The function has successfully executed, and if I go into Slack, there's my message. So if this was a real environment, all sorts of alarms would be going off at this point. Perhaps a ticket would be created, or pagers would get contacted. You could even implement systems that remediate this drift automatically. All right, let's zoom in on a CI/CD system for infrastructure as code. This is the orchestration that moves code from source control to your live systems. So here's a typical CI/CD system for CloudFormation. In this diagram, once the code is pushed and merged into the release branch, Code Pipeline picks it up, runs the code through a series of checks using CFN-Lint, which is an open source tool for linting templates that's maintained by the CloudFormations team. The CloudFormation linter checks for common misconfigurations and best practices. We also run the template through CFN-DAG, which is an open source tool maintained by Stelligent that checks for insecure patterns in CloudFormation templates. Both of these are static code analysis tools that should be run on your local computer before submitting into the pipeline. Once the templates pass those static checks, we run it through TaskCat, which is another open source tool that's maintained by the AWS Quick Starts team. TaskCat deploys your templates in multiple AWS regions and generates a pass-fail grade for that region. TaskCat validates that your template will successfully deploy in a region. You could think of it as an integration test. Once everything passes, we create a change set in CloudFormation. A change set is a manual gate that reports on your changes to infrastructure that will occur if you were to deploy the template. At this point, somebody would review the change set. If something doesn't look right, you simply delete the change set and nothing gets deployed. If everything looks good, you execute the change set, resources are deployed, and it goes into the live environment. Once deployed in the live environment, the system constantly checks the state of the live environment to validate no drift has occurred. If you're using the CDK has a high-level construct called CDK pipeline that configures a pipeline for you to deploy your CDK application. A pipeline consists of several stages, which represent logical phases of the deployment. Each stage contains one or more actions that describe what to do in that particular stage. A CDK pipeline starts with several predefined stages and actions, but you can add stages and actions for it to suit the needs of your application. So let's take a look at a day in the life of a developer using GitOps. They want to push some changes to infrastructure. So I'm releasing version 2.0 of my stock picking application, and I need to make some changes to a security group that's maintained and owned by the operations team. Well, I'll pull the infrastructure code from Git down to my laptop. I'll create a new branch, and I'll make that change. I'll then test my code locally before pushing my changes. I know what tests to run because they're all documented in the pre-commit hooks. So I'm pretty confident that my changes are going to pass code review. Since I'm feeling good, I commit and push my code, and I create a pull request. I'm able to track the process of my pull request. I see that all tests have passed, and it's been assigned to my two favorite reviewers from the ops team. They comment, "Looks good to me," and the code is merged to the release branch. The code is picked up by the CI/CD pipeline, and integration testing starts. If tests pass, CloudFormation executes the template. Resources are provisioned, and the code is merged into main. Awesome! Live state is constantly checked to validate that it matches the latest in mainline, and if a diff is encountered, you alert or reconcile the change. There are three main tools that you'll work with in a GitOps environment. You'll need to store your code in Git. You can use AWS Code Commit, GitHub, GitLab, or Bitbucket will all do the job pretty nicely. You'll need to codify your infrastructure declaratively. Here, CloudFormation, the CDK, or other partners such as Terraform are popular choices. And lastly, you'll need a CI/CD system that orchestrates the movement of your code from Git to the live environment. There are a bunch of popular solutions such as AWS Code Pipeline, Code Deploy, and Code Build. Again, you could use tools from partners such as Jenkins, Travis, or Circle CI to name a few. Infrastructure as code can take many forms. For example, you can use GitOps with the Amazon Elastic Kubernetes Service, or EKS. What you see here is a project that helps you build a complete Amazon EKS cluster with a CI/CD pipeline using the AWS CDK. This solution is available in the AWS Samples GitHub organization. We also have an example of GitOps with the Amazon Elastic Container System, or ECS. ECS, continuous deployment reference architecture that you see here, demonstrates how to achieve continuous deployment of an application to ECS. The solution is available in the AWS Labs GitHub organization. So you joined AWS Summit to learn, and you can keep learning beyond the summit with resources from the AWS Training and Certification for DevOps. We offer 45 online digital trainings that's available on demand. You can go deeper with the 3-day course that's instructor-led. You can gain credibility and confidence with 2 related certifications. You can also explore labs, white papers, and other technical resources by downloading the AWS Ramp-Up Guides. Thank you so much for your time, and don't forget to complete the session survey. We really value your feedback.